Hey guys, welcome to lesson 513 day 2. It's just some more practice with the switch and solve method of finding inverses because there is one particular style of problem that isn't really workable with that listing operations method. So we are going to talk about that situation and just get a little bit more comfortable with the switch and solve method altogether. Okay. So this right here is just the steps that we talked about yesterday, so keep those in mind as you're going through this. Now, that listing method is great, and it works for everything we've done so far, and if that's your method of choice, I'm okay with it. However, problems like this, where x is in the denominator of a fraction, don't quite work for that method. And the reason for that is that it's not really easy to describe what's happening to x when it's on the bottom of a fraction. There really isn't a good way to do that. And so you have to use the switch and solve method for this kind of situation. So let's go ahead and get started with these problems. And remember our steps, right? So we're going to go ahead and start by switching our x and y. Now you just have to remember that this h of x, this is y for us. Okay, so don't get confused by that. You could just always rewrite it as y equals. So now that I know that, I can say, okay, well, let's flip-flop x and y and say x equals 13 over y plus 3. Okay, I just flip-flopped the x and y. So once I do that, the next step, and this is always going to be your next step for this style of problem, okay, where the x is in the denominator, we need to multiply both sides by whatever is on the bottom of a fraction. Now the reason for that is that we want to get rid of this fraction because otherwise the y is just trapped down there and we can't free it. And our goal is to get y by itself. We can't do that until it's out of this fraction. So that's why we're multiplying by the bottom. Anytime you multiply a fraction by whatever's on the bottom, they cancel. Okay, and of course, whatever you do to one side, you must do to the other. So the left side ends up with x times that y plus 3. Okay, on the right side, the y plus 3's cancel, so you're just left with 13. At this point, we need to start making more moves to get y by itself, and it's kind of trapped in these parentheses with this 3 right now, but what we can do is get rid of this x. Right now it's being multiplied by the y plus 3, so we can go ahead and divide both sides by x. Okay, so that'll cancel the x's on this side, and we'd be left with just y plus 3. And on this side we have 13 over x. Okay, and then we have one more step. Not a good color choice. One more step, and that is to get y by itself finally by subtracting 3 from both sides. Okay, because that's the last thing stopping y from being alone. So that means that y equals 13 over x minus 3, but remember we like to write it in our proper inverse notation, which is this f negative 1 thing. So I'm going to write it with that instead of the y. And this is our final answer. And this process is pretty typical for any of these kinds of problems, unless if they get super complicated. Alright, next we have a cube root situation going on. So let's start again with our basic steps. Remember that this is just another way to say y for us right now. So we'll start by switching them. X equals the cube root of y plus 1. So now we need to make moves here. Right now, y plus 1 is trapped in this cube root, and there's nothing else going on outside, so we have to start by getting rid of this cube root. The opposite of cube rooting is cubing. So we have then x cubed on the left, and on the right, we just completely get rid of that cube root, so we just end up with y plus 1. And then we just have to get rid of this plus 1. So we do the opposite, which is minus 1. Those cancel. So we end up with x cubed minus 1 equals y, and we are pretty much done. So I can write for my final answer that f inverse of x is equal to x cubed minus 1. Alright, again, I'm just replacing these y's with the f inverse of x because that's the correct notation, because after all, we did find the inverse function. of f of x. Oh, also, I guess technically then this should be an h because that's a h of x. So let me fix that because that's going to bother me. Whatever letter is there, that's what you want to use. All right. So on to this one. We have a g of x here. You can use whatever letter you want, so don't let that throw you off. Again, this just means y. So, same steps. Flip x and y. And now we need to start getting y by itself. So the first thing we want to do is get rid of this plus 1 since it's like hanging out by itself. We can't really get rid of that 4 first because when we're working backwards, we have to take care of addition, subtraction first. That's what happens because in regular order of operations, multiplication comes before addition, right? So if you're moving backwards, then you've got to get rid of addition before you can get rid of multiplication. It's the same idea as like, you know, when you're undoing, like unwrapping a present, you have to start at the end, right? You have to start by taking off the tape. So now I have 4y cubed over here. I still don't have y alone. I need to get rid of that 4. Right now it's being multiplied by the y. So I can divide both sides by 4. Oh, I'm not able to talk today. So divide both sides by 4 to get rid of that 4 here. So x minus 1 over 4 on the left and y cubed on the right. We are almost done. Y is almost alone, but it's being cubed and we don't like that. So we're going to do one last thing. To get rid of this y being cubed, we just have to do the opposite, which is to cube root it. Alright, so that means that we end up with, on the left, x minus 1 over 4. And on the right, just y, because cube rooting a cube is just going to cancel the cube. And then I'm done. I will just rewrite this in the correct notation. I used a g this time because this was g of x. Alright, and that is it. Okay, one last problem here. We have k of x this time. So this one's just like the first one, where we have x in the bottom of your fraction. So let's start by flipping them. So x equals 4 over y plus 14. And then we can go about our next step, which is to multiply both sides by the denominator. In this case, I have a y plus 14 here, so that's what I'm going to multiply by. Whatever the bottom is, that is what you multiply by. Okay, so the whole point of that was that, so these will cancel. On the left, you have x times y plus 14. And then on the right, you just have a 4. Next step, we want to get rid of this x first, otherwise the y plus 14 is just trapped in there. And the way to do that is to divide. And the reason I'm dividing is because right now the x is being multiplied. So dividing is the opposite. So these x's cancel, and we end up with y plus 14 equals 4 over x. Now we just have one last step to get y completely alone, which is to subtract 14 from both sides. So we get y equals 4 over x minus 14. We're pretty much done here, but I'm just going to write it in my proper notation with the inverse thing. And now I am done. That is my final inverse. Give the open math problems a try if you haven't already, and let me know if you need help.